we are going to welcome Flynn in. I'm adding you in. Here you are. Hi, Flynn. So you are here to present Cooperating Clustered, Linker's new take on multi-cluster. So
that is
welcome.
what I'm here to present.
Awesome. Look forward to it. For everybody who is here, Flynn is super, super instrumental in making all of this work, all the content, and making sure the demo apps work and all that. So behind the scenes, he's been working away at this. So thank you so much, Flynn. And we'll remove ourselves and let you take it from there.
And go ahead and introduce yourself. I'm sure there's so many things and projects you're involved in, and we couldn't get through all of them. So if you want to add to your introduction, just do a little humble brag.
Well, the first thing I'm going to do, I think, is to actually share the thing that I should have shared a minute ago, since I think Hopin loves to stall while I'm doing this. Hey, look, there we go. Amazing.
Thanks, Flynn.
Woo. Yeah, so I'm Flynn. Hi, I'm a tech evangelist for Linkerd. I think that that Danielle and Lisa were giving me a little too much credit for how many KubeCrashes I've been involved in and things like that. But, you know, that's very nice of them. I appreciate that anyway. I've been doing cloud native for a while, and I'm going to be talking a certain amount about multicluster in general, about how Linkerd makes multicluster work well. Some of the ways it's evolved over time, and in fact, some of the things that you're going to see in a couple of other talks later today as well, using all this stuff. So off we go. Everybody pray to the gods of demos and things like that. All right. So on the agenda for today, we're going to talk about, what is this multi-cluster thing anyway? How is it that Linkerd helps with it? What's the whole cooperating cluster idea? And then we're going to do probably a fairly quick demo, since there's a fair amount of stuff to cover as well. All right. Oh, wait. And first, a note from our sponsors. Buoyant is, in fact, doing Linkerd Enterprise. We're very proud of it. We hope you'll come and check it out later. All right. So what's all this multi-cluster stuff about then? If you look back in history, we started off doing everything in terms of monoliths, where we just had, the application, it was all self-contained, and inside you would have a bunch of functions all calling each other. These were convenient in some ways and very inconvenient in other ways, and we ended up replacing those with this single cluster world, where instead of having everything be self-contained in one application, you would have a bunch of microservices running in a cluster, which should be familiar to everybody, and then all the microservices would talk to each other. This was handy in that the microservices scale better. They permit a lot of advantages in terms of development, because each of your teams can truly work and release independently, and these are all good things. It's more complex because you have to start worrying more about distributed system stuff and things like that. And you also get into this interesting thing, which Dinesh was kind of talking about a second ago, where your cluster can catch on fire and bad things happen. So that leads us into this idea of multi-cluster, where you would have a disaster recovery cluster just hanging off on the side. Your users would be talking to your normal cluster, and if in fact it catches on fire, then the users get routed over to the disaster recovery cluster, and this is a good thing, right? It's kind of an expensive thing, though, because you end up with an entire cluster running, doing not much when things are working well. So this tends to bring in this world where you've got this idea that you have, instead of a single cluster that's doing everything and then you've got a standby, you could actually just go through and let them both be running at all the time, right? Then some of your users can talk to the one, some of your users can talk to the other. This turns out to work particularly nicely when you have to deal with things like, GDPR comes to mind, right? Where you really want your European users to be talking to your European cluster. Okay. Of course, in this case also, where, if one of them dies, then you can end up routing the users over to the other. Sometimes that has other problems, but that's the idea. Other problems, like maybe you're not actually allowed to route the United States users over to the European cluster or something along those lines. Okay, But all of these things have a few common threads to them. One of them is that although the diagrams that we've been looking at are becoming more and more complex, they're all still fairly simple to reason about. You have multiple clusters. Each cluster is running the entire application, which means that they all act very much like each other. You don't really have to worry a whole lot about whether a thing in a cluster. I'm sorry, I got distracted by the comment there about go to KubeCon if the pub's not for you. Well, yeah, that's true. But yeah, so they're all fairly simple to reason about. You can use the cluster boundaries to isolate clusters, isolate a given cluster from problems in another cluster. They can help you with compliance. They can arrange it so that if you have if you have a failure in one cluster, it shouldn't affect the other ones. But also, if one of your developers accidentally pushes the wrong thing into one cluster, then that also should not affect the other clusters, right? And it's also interesting to note that although you don't necessarily want to do things this way, it is possible to actually do manual changeovers. Even if you don't have any automation set up, even if you don't have anything fancy, if you notice that one of your clusters is on fire, you can sit down at the terminal and go and mess with the network and point everybody to the other cluster. Again, this is not how you want to do things, but it's a way you can do things. Things that are less good in the common threads here. They're all fairly expensive because you're duplicating the entire application. This tends to result in some clusters that are busier than other clusters. It tends to result in things like a given cluster's hardware is going to be driven by the most obnoxious thing running in it. And so you can end up over provisioning for some of your simpler workloads in the cluster. You introduce a bunch of extra complexity there. Another thing is that back in the bad old days, we found that switching from one cluster to another cluster tended to be risky all by itself. And there are a bunch of reasons for this. One of them is that back in the bad old days, it was not uncommon that the shift would be manual. You'd have somebody who was sitting down and typing commands to run it. But another thing that's a little bit more subtle is that all of these things tend to be pretty long-lived clusters. If you have to stand up your entire environment every time for each one of these, the tendency is that you keep them around for a long time. And unfortunately, that means the tendency is that people will mess with them. And you can easily switch over to one cluster, switch from one cluster to another, and then find that the second cluster isn't actually identical to the first cluster in important ways that nobody noticed before because they were serving different groups of users. Finally, and this kind of gets back to the thing I was talking about with over-provisioning and what's driving the scale of the clusters and such. Fundamentally, if you're looking at this as a cluster for an entire application at a time, we end up replicating a large amount of the things that Kubernetes is actually really good at handling for us in terms of scaling. For example, it becomes harder to go through and scale exactly the piece of the cluster that's running the workload that needs it without also throwing hardware at other things. And it just complicates your Kubernetes management a lot. And there should really be a way that we should be able to use the tools that we're using to help us out instead of fighting with us. Mate is asking, what do you think of using multiple clusters to segment traffic? Mate is a coworker of mine, so he's clearly just poking at me here. Have a cluster mainly used for compliance, payment services, things like that. I think it's a great idea. I think that we're about to get to a slide that talks something about that. So it becomes interesting to think smaller than an entire application at a time here, where instead of replicating this whole cluster, suppose instead we split it into multiple clusters. Suppose that we give each workload or group of tightly associated workloads their own cluster, and then we just allow the clusters to talk to each other. Obviously, we're going to need to arrange it so that it's safe to do this. We are absolutely going to need security and reliability and all that stuff as we communicate between clusters. But this offers us some really, really nice advantages. And this is the model we've started to call cooperative multicluster, where rather than taking the entire application and using the cluster to draw a boundary around your whole application, which you're then going to replicate, suppose we instead use clusters more like namespaces, where you have a workload within a cluster and you're using the clusters to provide isolation between workloads. There are a lot of interesting things that you can do with this. So, one kind of fascinating thing about this, it's still fairly simple to reason about, because you can now be thinking in terms of a cluster per team instead of a cluster per environment. You don't have the European cluster and the American cluster anymore. In general, instead, you might have the payments cluster or whatever. I feel a little bit weird saying that, because some of the demos that we're working with, we are splitting them kind of geographically, but well, we'll get to that. That's mostly for demo reasons. Another thing that's interesting about this one is that the microservices end up being protected from each other, not by namespaces, but by clusters. This is a stronger separation between microservices. So you do not have to worry, at least you don't have to worry as much about whether you have things set up like, whether you've accidentally dumped some RBAC into a cluster, or whether someone has maliciously dumped RBAC into a cluster so that the people in a namespace can cross namespaces. That becomes harder when they would have to cross cluster boundaries entirely. It also lets you tailor the cluster to the microservice and to the team. So if you have a team of people who are absolute Kubernetes experts, then you can arrange it so that their cluster has less restrictive permissions, if that will help you. Alternately, if you have a cluster for a team of Kubernetes experts, you might want that to be more restrictive so that they don't go through and mess with things more than anybody else is expecting. You can scale clusters individually to match the needs of a particular microservice. And all of these things end up working out pretty nicely. The less ideal things, it can be more confusing. It doesn't necessarily have to be. It can be more confusing because you do need to arrange it so that your team, the people who are working on these things, you need to arrange it so that they understand which things are running where. Honestly, you can mostly do this with naming when you get down to it. And also, the networking here gets to be hard enough that there's really no way that you're going to be doing this stuff by hand. Trying to go through and edit all of the stuff to secure the communications between multiple clusters in this fashion is the kind of thing where you really need to use a service mesh. On the other hand, we have service meshes these days. And one of the good things, again, is that using this model is actually taking full advantage of all the things that a mesh is good at, because it gives you security and reliability and observability even across clusters. There's a comment over here. A single web session using multiple app servers can be tricky at times. Yes and no. You need to pay the same kind of attention to things like sticky sessions for stateful applications as you always would. But again, the service mesh is the one that's handling the communications across clusters. And so if you let the mesh do the things that it's good at, then that's not really any harder than having them in the same cluster. If you're talking about things bouncing across between, if you're talking about situations where a user might connect to one web server in the beginning and then they might end up going to another one, yeah, that's true. But that, again, is pretty much the same problem as if you're doing round robin and you have multiple instances of the ingress in a single cluster. So again, if you're using a mesh for the things it's good at, it doesn't really get that much more complex. Okay. So with that in mind, I am here with Linkerd. Linkerd is a service mesh, and we can do multi-cluster. So let's talk about that a bit. fundamentally, what we're dealing with is this idea that we want Linkerd to make this arrangement possible. And we also want it to allow us to make this arrangement possible, even if these clusters aren't with the same cluster provider and they're not sharing well, they have to have some IP connectivity, but the only connectivity between them might be the public internet. We'd also like to take advantage of it if they have tighter network coupling. So this is where the mesh is useful, where the mesh really shines. Another thing that we want to make possible is we'd like to arrange it so that, yeah, you can go through and scale a given microservice, but that maybe you want to just be able to split that workload across 2 clusters entirely. Possibly that's because you need to isolate them between regions, or possibly it's because you need to just deal with something where you don't want all the instances of it in the same cluster in case that cluster crashes. So we'd like for all of these things to be possible. It turns out we can do that. So let's take a deeper dive here. Under the hood, if we've got a single Kubernetes cluster, which has 2 Kubernetes logos in it, I'm not sure exactly why, but you can imagine we've got a couple of workloads that are talking to each other. And normally this is just going to be plain old TCP going between one workload and the other workload, right? As soon as you throw a service mesh in, then Linkerd in this case starts mediating those communications. So the workload on the left will end up talking to its Linkerd proxy, which will end up talking to the proxy for the workload on the right, which will end up talking to the workload itself. It's always funny to do this diagram because it looks like all we're really doing is slowing things down. But the important part here is that as soon as the proxies get involved, Linkerd gets to mediate as well as measure all the communications. So as soon as Linkerd is involved, the communications are all MTLS. We can measure what's going on. We can give you stats. There's a bunch of good things that go along with having the mesh in play. Now, of course, the workloads are not actually monolithic like that, right? Oops, sorry. I'm jumping ahead of myself here. Also worth pointing out, with Linkerd, we have the Linkerd control plane in play as well, and the proxies will end up interacting with the control plane to get important information about what's going on. All right, if we take a bit of a deeper dive into the control plane is not actually just, the control plane. There are several different controllers that are part of it. The destination controller within Linkerd is pretty much responsible for knowing which services are associated with which pods. And, we could literally spend an entire talk just on that. I wonder if we should probably do a Service Mesh Academy about that. Services in Kubernetes are pretty complex. They have, on the one hand, a service is the thing that is responsible for associating a DNS name and a cluster IP with some workloads, but it's also responsible for keeping track of the IPs of all of the pods that form the compute resources for that workload. So they have these 2 really, really different functions. Service meshes have to worry about them, and the destination controller within Linkerd, it's actually destination and policy working together. But one of the big things they keep track of is understanding how to associate the name and the cluster IP with a set of endpoint IPs. The policy controller, unsurprisingly, also deals with, authorization policy and such. And the identity controller manages the workload identities, which let us do things like understand which workload is talking to which other workload so that we can properly authenticate those. Okay. I just flipped back here to catch some of the comments. From a cost perspective, a cluster for each microservices seems quite excessive. Are you using shared masters or something like that? You could. Broadly speaking, the cluster providers that I work with, there are usually ways that you can get the cluster provider to be fairly polite about this. I think that's probably the simplest way to do it. Obviously, if you're running it all on bare metal yourself, you have a lot of control over this. But even if you're using cloud providers, there's usually a way to do that, or a way to manage it anyway. Another thing is that, as I think I mentioned earlier, you don't necessarily have to always do a one-to-one correspondence. You could have groups of microservices that are related in a single cluster as well, and that gives you more tools to balance it. Great comment, though. Okay. So that's a little bit of a deeper look into Linkerd's control plane. It feels a little odd again doing the high-level deep dive, but that's kind of what we're doing here. So another thing that's happening is that it's also worth pointing out, kind of as we were talking, that you've got within those pods, you've got the proxy and you have the application and you have a service which is outside but is still very much, sorry, a Kubernetes service resource, which is not part of the pod but is very much associated with the pod. So if we're going to start doing multi-cluster here, and we imagine that we've got these particular workloads, they're now in different clusters, lots of things happen. The first one is that we end up getting a new controller that's part of the control plane. We now have a service mirror. A service mirror. It kind of does what the name implies. It mirrors services back and forth. We will then create a link resource. In this case, we're going to link our left-hand cluster to our right-hand cluster. Links are unidirectional. We could certainly do two link resources to go both directions, but I'm just going to show it in one direction because otherwise this diagram looks really, really messy. What the link resource does is it tells the service mirror in its cluster how to talk to the Kubernetes API server in the other cluster. It will then use the service mirror, in this case in the left cluster, will then use the API server to find out about that service over there, assuming it's been marked for export. And the service mirror will then create a mirror of that service in the left-hand cluster. Where our real service in the left-hand cluster ends up pointing directly to that pod, our mirror service does not. The mirror service points to a gateway, and that allows the Linkerd proxy in the left-hand pod to talk to this service to find out how to talk to this gateway, which then lets it talk through the gateway to the other Linkerd, and now you've got traffic flowing and everything is great. It's also very important to note this is a Linkerd talking to Linkerd. All right, I'm lying slightly. There's also a proxy in the gateway, but that just makes things messier. But the other important thing here is that these are still MTLS, and we still have observability for them, so we can still see what's going on. This is the way it works from Linkerd 2.9 to Linkerd 2.13. This really works great as long as you have IP connectivity, but there are IP connectivity in the sense that workload 1 has to be able to talk to the gateway in cluster 2, right? There are two caveats, though. The first one is there's a little bit of latency involved here because we make a connection from workload 1 to the gateway and then from the gateway to workload 2. It is not usually a lot of latency because Linkerd is fast, but there's some, and sometimes people want to get rid of that. Another one which can be a little bit more irritating is that as far as workload 2 is concerned, the request that it's getting is actually coming from the gateway, not from workload 1. And so this can make it challenging to deal with authorization and such. So what we've decided to do as of Linkerd 2.14 is to have a mode where we can get rid of the gateways entirely and just speak directly from workload 1 to workload 2. There are some really good things about this one. Identity gets preserved. All the existing MTLS stuff that you're already used to, it just works. All the policy stuff works. Less latency. It requires a network where you can speak directly from a pod in one cluster to a pod in another cluster, by which I mean if you find the IP address, the cluster IP address of the pod in the other cluster, and you speak from your first cluster to that IP address, it has to work. Sometimes that's challenging. If we look under the hood with this in 2.14, once again, this is the way that looked for 2.9 through 2.13. And it looks exactly the same if you want to use gateways with 2.14. Totally supported, works great, rock on. In fact, we do some of this in the demos that you're going to see in some of these other talks too. You don't have to use gateways though. The gateway can just go away. And if you tell it to, what that means is that the service mirror, rather than creating a gateway and everything, it just points this service directly across to the IP address of the pod in the other cluster. Very, very important. I'm talking here about direct IP communication, but remember, it's still a Linkerd proxy talking to a Linkerd proxy, which means it's still MTLS and it's still got authentication and all of that. So it is safe to do this, which is pretty cool. It's also worth noting that you don't actually have to do this 100% of the time. You can certainly do this where we're doing flat networks. We have that thing going across, but then if you want to, maybe you want to use a gateway to go to service 2. That will work at exactly the same time as you're doing all the flat network stuff. You can mix and match as you need. And we will talk about a particular reason in 2.14 why you would want to do that, because on the face of it, it feels kind of strange, right? But there are a couple of really good reasons why this can be important. Okay. Some details that are not really shown in this diagram because it makes the diagram too messy, but that I have talked about some. The first one is links are one way. This is okay because you can do a link in each cluster pointing in the other direction. So you can do this bidirectionally. It's fine. But it is important, if you put in one link, you're not going to get it both directions. You'll only get it one direction. You have to annotate services to allow them to be mirrored across clusters. The service mirror doesn't just go and grab every single service it can find, because that would be absurd and probably break things. So we don't do that. Instead, there's an annotation that you put on. I'm sorry, a label that you put on, not an annotation. I'm so sorry, Mate. He's probably sitting over there having heart palpitations or something. A label, not an annotation. However you do this, whether you're doing it with a flat network or whether you're doing it with gateways, you must have a trust anchor that's shared across the clusters, because that's the only way MTLS can work at all. MTLS is always about arranging it such that you know who is talking to whom. You have certificates that must go back to a single trust anchor so that they can be verified on both ends in both clusters. Also note, I'm talking about both clusters. I keep talking about 2 clusters. Use as many as you like. It's fine. But they all have to have the same trust anchor. Flat network multicluster. Again, you must have direct IP connectivity between arbitrary pods, no matter what cluster they're in. And that implies that your clusters must be using different cluster side arranges, because otherwise some of their pods can stomp on each other and things will get very, very confusing very quickly. Depending on cloud providers, this might be a really, really difficult thing to arrange. It might be impossible with some cloud providers. So, this is part of the reason why we keep supporting gateways in 2.14. Another note is that giving each cluster a distinct identity trust domain can help with auth policy, just because it can make it a little bit easier to know which specific identity you're talking about. But, just something to bear in mind. Okay. Not seeing further questions. That's probably a good sign. I'm now going to spend a little bit of time talking about the demo architecture that I'm going to show you some things about, and that Ambassador Labs will talk about in their talk about Emissary, and that the Cockroach Labs people will talk about in their talk about CockroachDB. So pay attention. There will not be a test, but there will be other talks talking about this architecture. We have a UI that looks kind of like this. Some things that are relevant to note here. First off is places where you see these little flags are representing users. So this is a Canadian user. And over here we have an American user. And they will be wandering around in these grids of cells doing things, marking themselves with smileys. Also, as they go, the North American users will make the background more red, and the European users will make the background more green as they go. What exactly they're doing is honestly not really the point of this demo. It's just kind of something to watch. Really, the point of the demo is that we have arranged it so that the American side of this, the North American side of this, is set up within 2 clusters, and the European side is set up in a 3rd cluster. And we have it arranged such that if we have, when you log into the demo, if you log in as a North American user, Canadian or United States, then you can only see the backgrounds for North America. And if you log in as a European user, Germany or Spain, then you can only see the backgrounds for Europe. Right now, this screenshot is from logged in as our special user, which gets to see everything. For compliance reasons, that might be a very, very bad idea. And for demo purposes, it turns out to be a useful idea. Let me interrupt myself here since we've found some Q&A questions. Bin packing and cost optimization, do they not become a concern if running a cluster per team or workload? Kind of, but I tend to feel that in some ways, I kind of feel like that gets back to Per Johnson's, I'm probably pronouncing that wrong, I'm sorry, question about excessive costs per clusters. To my way of thinking, being able to use clusters to isolate things gives you more tools for being able to optimize costs rather than fewer tools, because you can go through, you have to worry less about things like you have a cluster that must be made very large to deal with a particularly nasty workload, and then everybody is constantly having to worry about whether they're getting starved out or things like that, right? So it's a different way of balancing things, I guess, might be the simplest way to answer that one. Or I hope that answers. Another question, how is this different from Scupper? I'm assuming that means how is Linkerd different from Scupper? I'm going to come back to that because I need to go and look up Scupper again to make sure it's the one I'm thinking of. So Lisa, if you can remind me about that afterwards, I'd appreciate that because I might forget. Okay, back to this. Underneath, as we go through and we look at this, we have the UI up there in the corner, which you can almost see behind the KubeCrash logo. And we have clusters called US West, US East, and EU Central. Each of the clusters is running an emissary as an ingress controller. Each of the clusters is also running 3 nodes of CockroachDB, and each of them is running the custom application, custom logic for the world's demo itself. Please don't interpret that to mean that the world's logic is particularly profound or complex, because it's not. But that's what we have running. There we go. We, of course, have Linkerd everywhere in this thing. And we also have, in our US West cluster, we have a workload running that is basically being the user from Canada. So it is doing things like going through and posting a smiley and then finding out which cells are neighboring and picking one to move to and moving to it and doing another smiley, and trusting that the database is keeping track of all the information to track visits and do the backgrounds and all this stuff. And I believe that Rob from Cockroach will be talking quite a bit more about the database underneath there. In US East, that's where our American user lives. And in EU Central, we have the German and Spanish users for European. Ahmed asked, do we have GitHub of the demo? We do, and I will put a link to it up a little bit. Well, okay, the demo link will appear, but let me also put it over here for Lisa to put in the chat. Wow, I can't type. All right, there we go. But yeah, all the source for this is available. Just, you know, try not to scream too much when you look at it. Lisa, I think the opens in a new tab part is not supposed to be part of the URL there. One other thing that I want to point out about this particular slide is this particular stage of this slide is our users there. You'll note do not have Linkerd next to them. And that is because they are not actually part of the service mesh. The only thing they can do is talk to emissary. They cannot talk to any of the other things. Basically, I have them parked in these clusters because it was more convenient for the demo than firing up another cluster to run them in, or another 2 clusters, really. Part of what's going on here is that, sorry, part of what's going on here is that I have to make that repo public. Okay, so I'll do that after I finish going through this. I'll turn that public and people will be able to see it. Sorry about that. So part of our organization of clusters here is because, and JD Pawar mentions the Spring 2023, which is a fine repo to look at, but that is in fact for KubeCrash as of the previous KubeCrash in the spring, not this KubeCrash in the fall. So what I was going to say is that this demo is using this geographic separation rather than separating clusters for workloads, mostly because if you look in the repo, you will find that there's setup stuff in there to be running this using K3D clusters on your laptop. And trying to run something like 9 K3D clusters on most laptops does not work very well. So we split it up this way just to make it simpler to set up that way, to set up, running on a laptop. I'm going to add instructions for doing this differently. We can slice and dice this in a lot of different ways. But, all right, moving on then. So when the browser goes through and talks to one of these emissaries, the emissaries Linkerd will go through and talk to the world's logic, which will talk to Cockroach. This is the data path for everything. Same thing happens, if the browser talks to one of the other emissaries, the same thing will happen in another cluster. And it's also worth noting that the emissaries, it's also worth noting that the emissary, like I said, that's the only thing that the players get to talk to. And further under the scenes, we have CockroachDB using Linkerd's gateway multicluster so that all of the Cockroach nodes get to talk to each other. And further, all of the emissaries can talk to each other. This becomes important because if you are, say, logged into the demo as a European user and you connect to one of the US emissaries, you're going to get switched over to the European emissary. The cockroaches all need to talk to each other so that they can keep the database in sync. And it's honestly pretty cool looking to see the way you can be doing fully distributed SQL across this thing using Linkerd multicluster. So basically everything over here Linkerd is running all through it and powering the whole thing, which is something to bear in mind as we go through and look at all of this. So one other thing is, although we are actually doing this demo with all the clusters running in Civo, they could be across other cloud providers entirely. Okay, there's the demo source code. I'll make it public as soon as I get through the rest of this stuff. And now I'm going to do a very quick demo. So everybody cross your fingers. All right. first things first. Is my demo still running? Hey, look, my demo is still running. I just saw the people moving around. So yeah, we can watch this, and as we go through, then you can see that it'll, you can watch as the Canadian user wanders around. You can see the Canadian user is gradually making things more red, and you can see that the German and Spanish users are gradually making things more green. Uh-oh, my network just hork out here. Okay, I think we're still okay.
We weren't sure if it was us or you, but Flynn, we got to make sure the demo's quick because we're running over time.
Oh, okay. Then we'll do this really, really quick. All right.
Okay.
So, fortunately, the demo part of this is really looking a little bit into, I'm actually going to skip this. Well, I would have skipped that. All right. Let that run. Let's skip some of that. All right. Don't need to check some of those other ones. This is basically just showing that some of the ways that all of these things work. You can see mirrored services in here. You can also go through, this is really the most important thing I want to call out since we are over time. I'm sorry about that. Those mirror services are more important than they seem because we're using the public internet here, and Linkerd is the one that is allowing us to securely go over the public internet for this. All right. Actually, you know what? There is one other thing I need to point out here, which Cockroach is using a stateful set. So even if we're using flat networking for this, we will still be using gateway stuff for Cockroach so that all of the headless service magic just works in Linkerd. And that is something where after 2.14, I think we're going to make that happier as well. I am going to stop here because we are over time. I'm sorry about that.
But it's been great. So we will jump in and say, if you do have questions, please ask Flynn in the chat, the comments part of it. So just, if you're asking questions in the Q&A, some people can see them and some can't. So just the comment on the stage is the best place to ask for it. So thank you so much, Flynn, for that. Flynn,
and Flynn is really with the energy behind putting this integrated demo together and worked with all the companies and all the people and sort of kind of thought up the whole construct of it. So thank you, Flynn. We don't mind that you went a little bit over since you did such a good job setting the stage for everybody else who's also doing the demo. So that was really great.
But I kind of mind, but
No, and then apologies to everybody that asked questions earlier. We didn't realize that not everybody could see the Q&A, and like most of us couldn't see, but I just found it. So I'm going to cut and paste a few of them in. The ones that were from Flynn's talk, I've already put in. The rest of them are from earlier talks, but some of the presenters might still be around backstage and might jump in and answer them. So I'll get those questions in the chat now, so since it's between presentations. And so was that it, Flynn? Because we're going to bring in our next presenter.
That's pretty much it. Other than, you should check out Linkerd Enterprise. It's cool.
Awesome. Thanks, Flynn.
Thanks much.
I got it.